Here we're working through another example of finding a confidence interval for population mean, but this time we're going to use technology. We're going to use the web app whose URL is at the top of the screen. This is another thing that StatCrunch will do for us, but because we're not together and StatCrunch has been a little flaky this semester, I'm going to stick to the web apps as much as I can because then we won't have the issue about odd error messages and things. So here we're going to find a 99% confidence interval for the mean number of hours spent studying by public high school students. And the way we're going to get that confidence interval is we're going to randomly sample public high school students. So in this case, there's 24 public high school students. And among those 24 students in the sample, we found the average study time is 6.5 hours per week with a standard deviation of 2.3 hours. So that's what we need to be able to set up our confidence interval. And so if we go to the web app, when you first open it, it looks like this because it's giving a canned example from the textbook. So we're going to say, we're going to pick this option would allow us would allow us to type in data values. In this case, we don't have data values. Where is it? Oh, yeah. We don't have data values. We just have the summary information about the sample. So we'll say we're going to use summary statistics. Our sample size was 24. Did I remember that right? Yep. We have 6.5 as our sample mean. 6.5 is our sample mean, and 2.3 hours is our sample standard deviation. The problem asks us to find a 99% confidence interval, so I'll set this bar to 99%. And then over here is the output for my, my test. It shows me the picture of my confidence interval here. So the range of the population mean here is 5.182 to 7.818. It actually breaks it all down for us, so it shows us all the steps that we were doing before using the table. It tells us our point estimate was 6.5. That's the sample mean. Standard error is going to be approximated using sample standard deviation over the square root of the sample size. That's where that comes from. It's telling us that it's using this as the magic t-score. So it's telling us it got that from the table. And notice it's telling us what row of the table it got it from. The DF equals 23. That's because that's one less than 24. So it's telling us what row number it used, and then it's telling us what margin of error it got. So 1.318 hours is the margin of error. So it tells us all those things, and it eventually gives us the lower bound and upper bound of our confidence interval. So we would state that the true value of the population parameter mu is between 5.182 and 7.818 hours with 99% confidence. So that's what we would have in this statement, interpretation of our interval. We're 99% confident that the true number of hours, average hours that high school students have been studying is between whatever I just said, 5.2 and 7.8. So we could do all the steps, but you can see that the steps are done for us by the app. The second part of this problem asks that we repeat that only with 90% confidence interval instead of 99%. And so back in the app, all that means is that we move this slider all the way down here to the end and use 90% confidence. And you can see that my interval now is about 5.7 hours to 7.3 hours. And so you can literally see how it changes as you're moving it. As the confidence level goes up, the interval gets wider, which makes sense because the only way you can be more confident is by giving a wider range of answers. There's no magic trick. To be more confident, you have to say less. So as we move our confidence interval down to 90%, we're not very confident, we're not as confident, but we're able to give a much narrower range. The last part here, so this question here, of course, is asking about what I just talked about, but the last question here, how large a sample size would you need if you wanted your population estimate to be within 1 hour of the reality with 99% confidence interval. So to do that, we need to set this at 99%. And then we're talking about changing the sample size. Like how big would the sample size have to be for the margin of error, this number here, to come down to 1. So there we're 0.013 above 1 with a sample size of 38. And there we're 0.9987 with a sample size of 39. So those are actually equally close to 1. So either one of those would be fine as an answer, which is good to know. If you know ahead of time that you would like a certain tolerance in an estimate, then you can actually work backwards and figure out what sample size you need. And that might help you in the design of your experiment or the design of your of the way you're giving your survey.